Welcome to this video lecture on the topic antenna arrays. So array antenna is a system of similar antennas oriented to get the greater directivity in the desired direction. So it is also defined as the radiating system consisting of several spaced and properly phased radiators. The total field produced by antenna array system is the vector sum of the field produced by individual antennas of array system. So if the antenna is said to be linear, if the individual elements are equally spaced. So it is the linear antenna is the equally spaced elements. The types of array antennas, broadside array and end-fire array. So in the broadside array, the direction of maximum radiation is perpendicular to the antenna array axis, where in this diagram 5 antenna elements are taken which are equally spaced with a spacing of d, and direction of maximum radiation is perpendicular to the array axis. And the end-fire array, the direction of maximum radiation is parallel to the array axis. So first one, broadside array, it is which number of identical parallel antennas are set up along a line drawn perpendicular to their respective axis. The individual antennas are equally spaced along a line and each element is fed with current of equal magnitude, all in same phase. So it is radiates in broadside directions where there are maximum radiation and relatively little radiation in other direction. So the radiation pattern of broadside array is bidirectional. End-fire array, it is an end-fire array that individual elements are fed out of phase, usually 180 degree. So in which the number of identical elements are fed with equal magnitude but phases varies progressively along the line in such a way to make the entire arrangement unidirectional. So end-fire may be defined as the arrangement in which principal direction of radiation coincides with the direction of the array. So the end-fire array may be bidirectional, two element array fed with equal current 180 degree out of phase. And collinear array, antennas are arranged coaxially, that is antennas are mounted end to end in a single line. The individual elements are fed with equal in-phase current as is the case of broadside array. So the collinear array is a broadside radiator which the direction of maximum radiation is perpendicular to the line of antenna. Next, two element array. Here the array of 2 point sources with equal amplitude and phase is considered. The field pattern of two isotropic sources of equal amplitude and opposite phase is given. The arrays of 2 point sources with unequal amplitude and any phase is given by the end-fire array. So we are going to discuss both the patterns. So in this picture, two isotropic point sources situated symmetrically with respect to origin with the same amplitude and phase is taken. So to calculate the field at a great distance point P at distance r from the origin, and origin is taken as the reference point for phase calculation. The waves from the source 1 reaches the point P at later time than the waves from the source 2 because of path difference involved between the two waves. So thus the field due to source 1 lags while the field due to source 2 leads. The path difference is calculated by this variation. So d by 2 cos theta plus d by 2 cos theta is taken. So the answer is d cos theta. So in terms of wavelength, we can write the path difference as d by lambda cos theta, and the phase angle is given by 2 pi into path difference. So the total field is given by the vector sum of the both the fields. So E1 e power minus j omega by 2 plus E2 e power j omega by 2, where the two field components due to the source 1 and source 2 are added. So it is assumed that the amplitudes are same. So we can write the amplitudes E1 and E2 is equal to E0 and rewrite the above equation using E0 e power j omega by 2 plus e power minus j omega by 2, and we use the trigonometry formula for cos theta. We rewrite the equation of electric field 2 E0 into cos psi by 2. So it is also given by 2 E0 into cos pi beta d cos theta by 2, where path difference is taken. So for this field, we can draw the radiation pattern using maxima and minimum. in which we get the maximum point along the perpendicular direction. So at 90 degree and 270 degrees, minimum along the 0 degree and 180 degree. So this is the broadside array radiation pattern, which is bidirectional. And next, array of 2-point sources with equal amplitude and opposite phase. So for this we get the radiation pattern as shown in this diagram, where maximum radiation we get along the 0 degree and 180 degree, and minimum we get along the 90 degree and 270 degrees. So let's take the assessment. For long distance communication, which of the property is mainly necessary for the antenna? The answer is high directivity. And which of the following is false about the single antenna for long distance communication? So the answer is no side lobes. So thank you for listening.